relationship of pressure, volume, temperature, and the number of moles of a gas. The equation is PV equals nRT, where P is pressure, V is volume, N is going to be the number of moles of the gas, R is the ideal gas constant, shown down here, and which is equal to 0.0821 liters times ATM per moles Kelvin, and temperature is T. Now if you look at this constant, look at the units of the constant, we are going to always, for volume, have to use liters, pressure needs to be in ATM, N will be moles, and temperature is Kelvin. So whenever we use the ideal gas law, we do have to be in liters and in ATM. At standard temperature and pressure, or STP, it's 0 degrees Celsius and 1 ATM. We kind of talked about that when we did problems for the combined gas law. And again, we can reduce to Boyle's, Charles, Gay-Lussac's, and Avogadro's law. So this picture over here on the right is showing you that 1 mole of a gas at STP is equal to 22.4 liters, which is this is 22.4 liters here, which is I don't know, quite a bit bigger than a basketball when you're looking at gas. So you can just see the amount of gas that it would be right here, STP. So we're going to use this equation to solve a few problems here. Again, our equation I'm going to write up here, PV equals nRT. So what's the pressure in ATM exerted by a 0.5 mole sample of nitrogen gas in a 10-liter container at 298 Kelvin? So we're looking for pressure. So P volume is 10 liters equals N is 0.5 liters. R is always 0.0821. And the temperature, they give it to us in Kelvin, so we don't have to convert it. Right here, 298. So, solve for P. And I get 1.22. Our units are ATM. Okay. Next problem. What pressure in ATM is exerted by 0.325 moles of hydrogen gas in a 4.08 liter container at 35 degrees Celsius? Very similar to the other one. The only thing that's going to be a little different, they don't change our temperature to Kelvin, so we're going to have to do that ourselves. 0.0821 is R, and 35 degrees Celsius is equal to 308 Kelvin. So let's calculate pressure. Pressure is going to equal 2.01. Again, ATM. So there you go. For right now, I'm just going to skip this problem. It's going to be set up exactly the same, except for we know pressure. You're going to solve for liters. You're going to convert Celsius. I think there's some more on the next page that would be more beneficial to go through. So a sample that contains 4.38 moles of gas has a pressure of 0.857 ATM. What's the volume? Okay, we'll do, this is going to be exactly like the last one, so I'm just going to do this quick. Okay, N is 4.38. So we're going to look at the volume. And V equals Okay, this next one is one that I wanted to get to. It's going to be a little bit different. It's asking for mass. A mass of chlorine gas in grams is contained in a 10-liter tank at 27 degrees Celsius and 3.5 atm of pressure. Now, if we use our PV equals nRT, we don't have a variable that solves for mass. But we could solve for moles, which we can convert to mass since we know which compound it is. So let's write up. The pressure is 3.5. Volume is 10 liters. We do not know N. R is 0.0821. T is, what's 27? Plus 273, 300. So we're able to solve for N. Let's write N equals I have N equaling 1.42 moles. Now this is chlorine gas. I'm going to write chlorine gas here. Now remember how we do conversions here. We're going to have moles of chlorine on the bottom and grams of chlorine on the top. Whenever we go to grams to moles, we have 1 mole here. And chlorine's mass is 35.45, but it's Cl2, so we gotta multiply it by 2. So we get 70.9. That's our mass. Units cancel. So if we solve for the number of grams, we have 100.68 grams of Cl2. So here we had to do a little extra step. We can use what we find with our ideal gas equation and then solve for grams. And that's what you would do exactly the same here for this next one. You're just going to convert to moles and then you'll convert into grams. So I'm going to leave that one for you guys to do on your own. And we are going to go on to the last problem here. Sample of carbon dioxide with a mass of 0.3 grams is placed in a 250 milliliter container at 400 Kelvin. What's the pressure exerted by the gas? So this time it's kind of a little backwards than the last two. They're giving us grams. We're going to have to convert that to moles first and then plug that into our equation. So 0.3 grams of CO2. We're going to convert that to moles. We have grams. 12 plus 16 times 2, 44 grams equals at 6.82 times 10 to the negative third moles. Now if we write out our ideal gas law, pressure is what we're trying to find. Volume, 250 milliliters. Now remember we have to be in liters for the ideal gas law. We'll change that into liters. 0.25 liters equals N. We solved for was 682, 10 to the negative third moles. R is 0.0821 and temperature is 400. So if we solve for pressure then, I get a pressure of 0.896 atm. So this problem had a couple different things that we had to solve for. Because grams is not in our equation, we have to convert that into moles first. And then also our volume, you have to make sure you're in liters, so we have to change milliliters to liters. So a couple different things we had to do first before we can use our ideal gas law. That's a good example there. Okay, we're going to stop there And next time we are going to start on molar